with AI coming to take our jobs, we better know how it works. And to know how it works, we have to first understand how to even work with databases, because all AI is driven on data. That's why we're going to be doing a series on SQLite, or specifically SQLite3, which is a very lightweight database engine that is going to allow us to kind of create tables and just work with data, do very basic SQL commands to get us up and running until we eventually can create some cool AI stuff. So first, what is SQLite? We already kind of said that it is a lightweight database engine, and what that means is that it's specifically self-contained. It's self-contained in that all of the data we're going to be working with is going to be stuck to one file, and specifically a .db file. This file, you can almost think of it as a text file, kind of, but it's essentially what's going to contain all of our tables, not just one table, but several tables that you might work with in a database. And with this, you can either create all your tables from scratch or import an existing one and work on top of that. And it's also important to note that SQLite is serverless, so it's much more for kind of the beginning of scaling a business or a web project, you could say. And that gets us into when it's used. It's used often for smaller data sets, not necessarily like small data sets, but ones that we want to work with on a single computer. Or even in web dev, you can have like a smaller web application, use SQLite even, where essentially the user would interact with the UI, and then that UI would send a server request to your server, and that server itself could call a SQL command. But what's important is that it's all being run by the operating system with SQLite. We're not interacting with a cloud server necessarily, but learning SQLite, you're going to learn enough SQL and just how databases work to the point where it's going to be extremely easy to move this onto a AWS or a different cloud hosted database. And some cool examples of the kind of stuff you can do with SQLite even is create sign-ins, or tweets actually would use something kind of similar to SQLite, how people would send a post and then that would update a database. And we'll see that later on once we get used to just working with SQLite locally. Now, to get it set up, throughout this entire video, I'm going to be going over kind of a mix of both the command line version of SQLite and using the SQLite3 library in Python. So it's going to be kind of synonymous as we go. So it's going to show you how easy it is to do SQLite commands directly in Python, such as if you had a Python file for a Flask web server or any other kind of data science program you wanted to do and kind of jump between using this SQLite database. So with Python, we aren't going to have to install anything. It's just going to come with Python, and we just import that SQLite3. Now for Linux, and specifically the Debian or Ubuntu operating systems, or distributions of the operating systems, what we're going to have to do is sudo apt update, of course, followed by the install, as you can see here. And you can also check if you have it already. If you don't have it, it's going to give you that command not found. And once you have it, it will say it's found. And now it's also kind of recommended to install the dev library, as you can see how to do here with the apt install lib SQLite dev. What this is it's just going to kind of provide some easier of use functions. And these are already included within the SQLite3 Python module. Now for a Mac OS system, it's going to be very similar. You're just going to brew install SQLite, and it's going to come with the dev library that we just talked about. So we don't even have to worry about adding that if you're on Mac. I believe that should be SQLite3. But in order to actually check that it's installed, same exact thing, SQLite3 -- version, and it'll tell us our version. All right, now that we got the installation of SQLite3 out of the way, we can go ahead and start working to make our own database and our own table. So what we want to do first is I just have us creating a directory for where we're going to hold our database file. Remember, it's all contained in a single file. And inside of that directory that we just made, I'm now going to be able to use the SQLite3 command followed by the name of the database. And this database, it could already be made, it could already not be made. If it's not already existing, it's going to add the database for you. And if it does already exist, it's just not going to do anything. You'll just be completely fine and it'll open up SQLite normally, just as if you made a new one. And for the Python side of things, we of course have to import the SQLite3 library. And then we create this connection object, which essentially we are able to generate this object by using the SQLite3 library and the connect command from it. And then what this does is it just gives us that object that is connected to this database. And just like for the command line side of things, this does the same thing. If the database doesn't already exist, it's going to create it. So our my data directory will contain this new database file. And it's also okay if it already did exist, because we would just connect to what already exists. And one thing to keep in note is always make sure to close your connection. It's kind of like in C, closing down your pointer, because essentially what we're really doing is it's opening a file for us and we're working with inside of that file. All right, before creating a table, I just want to say that you can use the .help command once you're in SQL, and it's going to show you all of these different things and can give you help on them. And later on, we'll cover actually each of these individually, but that's not fun to start out with. So actually creating a table. We first want to discuss how there are 5, or I guess 6 main data types in SQLite3. You have the null, which is just it's completely missing. You have integers, which is just like in Python. You have ints, it's just a whole number. You have real, which is your float. And you have text, which is kind of like your string. And it's important to note that whatever text is going to be in your single quotes. You have numeric, which is kind of a more less strict version of the int. And then you have blob, which is for binary large objects, which this is dealing with raw bytes, such as we could even do song tracks or a bunch of AI data, but it's working directly with bytes. And we're not going to be discussing that quite yet, eventually. All right, why did we discuss the type of data types within SQL? Remember, SQLite3, basically it's using SQL. It's a database engine for using SQL. But why did we talk about those data types? We did because before, when we're going to create the table, we want to know what data type each column in this table should have. And each of these columns can be one of those 5 or 6 data types we talked about. To actually create the table, what we're going to do, if we're on the command line version of things, you're going to do create table, that's your command, followed by the name of the table. We're going to call this table smokers. And within parentheses, so this is what's going to go inside of that table, we're about to discuss the columns. We're going to call the first column patient_ID, and it's going to be of the data type integer. And then we just kind of do the same thing going on, and you notice that it's all kind of comma separated for each column. So then we make a age column, date of birth column, weight, and QOL, which that's going to be like quality of life. It'll be kind of a categorical data that we'll discuss. And after that, we of course have to close that parentheses. And we always kind of end our SQL commands with a semicolon. This shows that the SQL command, that's it. Okay, go ahead and run the SQL command. And that's important to know that that's only for in the command line version when you're using. Because as you can see on the Python side of things, it's almost identical. We're creating the connection, which we basically already did earlier when we created our database. That's basically creating our connection, because that opens up our SQLite program. So that's what we did with the create connection. we create a cursor, this is kind of our working object for playing with the database. And with this cursor object, we can run the execute method, and within that execute method, we can run any kind of like SQL command. This the same exact way. And you know that I just use these 3 apostrophes apostrophes. That's just because it's a multi-line string in Python. There's nothing special about it. It could have been single quotes and then we just jammed it all in one line, but I didn't want to do that. You see, it's the same exact kind of thing for creating database. You can notice it's going to get kind of repetitive between the command line version and the Python version. And this is for a point. It's making the same exact database, doing the same exact things, and it's hammering in that repetition. All right, but there's a couple things that we note are different. We do not close this parentheses, which we did here, with a semicolon. We don't do that because we're using the SQLite library. But other than that, it's all going to look the same. And we, of course, have to close off the function parentheses. So that's where this parentheses is coming from. And this is one place to note how they kind of differ between using the SQLite library and the command line is we want to make sure to use our connection object and commit our changes. Because essentially what's happening in here, we're working with a RAM or kind of play version of the database, if you will. And none of that's going to be saved to the actual disk. Remember, our database1.db file is actually located on disk. The SQLite files are located on disk. But this is going to actually save it to the disk when we use the commit. So it's just from RAM to disk. And we, of course, close it out. All right, that's already a lot so far. I hope you're keeping up. And we can also, if you just want to make sure stuff worked, the command line program will let you do the .tables, and it'll show the tables that you used or that you created, so you can make sure that the smokers table is there. And I do want to note, look at that pattern. Column name, data type, whenever we're creating this table. We have our column name, data type. And you can see how the more like very SQL specific commands are written in all caps. This is just kind of a convenience sake. You also notice, I guess I can put this out too, is we have our function input. We have what we're doing this function or SQL command on, and then we have what's actually happening inside the parentheses. I always like to look for patterns within the syntax to learn it quicker. All right, now we created this table. This is just kind of recapping what we just said. We created the cursor object using our connection, and we use the cursor to actually make the changes, and we commit. Use the connection object to commit what we've done to RAM and really save it to disk officially. And you can see, even if you're working in VS Code, this would show up whether you were doing the terminal or not. You would just go to the actual database file location just as a folder, and you see that we made our table. We have all of our columns that we wanted, and we have the smokers table, and yeah, no, we're starting to get somewhere, but we don't have rows yet, so we got to do that. Adding a row. It's all right to think of it as adding rows, but you can also kind of think of it as like adding a piece of data. I don't know. It's kind of technical, but we'll go on. So to actually add a row, we're going to use the insert into command, and then that's followed by the name of the table, followed by in parentheses. This is what we're going to be inserting. These are, if you can see, these are the name of each of the columns separated by commas. Followed by that is we use the values keyword, and in parentheses, these are going to be all of the data for essentially each cell you can think of for our row. This is what's going to be input into the row. So you have patient ID is 1, age 45, etc. And you can see that. And within Python, very similar to what we just showed in terminal. We're using the cursor.execute and the exact same SQL command with no semicolon, because remember, this is kind of like our semicolon, our closing parentheses for the execute statement, and commit and close. And just one thing to note too, after we've done this for the Python version or even just in your terminal, you may not see the database update. I mean, most of the time you won't unless you hit refresh. This is something I always forget to do. So after we hit refresh, actually looking at the GUI for our database, we will see that our data was nicely input. All right, adding a new column and updating data. Now that we added that first row, so sweet. We have a table, a single table inside of our database, and we have a single row. What about adding a new column? This is one part where it's kind of important conceptually to understand that we can't just like go in and straight up add a new column. We literally have to like quote unquote alter the table as a whole and add this column. And you can see we do that here using the alter table command, followed by the name of the table, which was smokers. And then what are we going to do to the table to modify it? We're going to add a column. The name of this column is height, and the data type is real. So remember, that's kind of like a float with decimal places. And with the Python side of things, just as what we did earlier, and you can even see here how I used just the single quotes and did it all in one line. Same exact command, and then making sure to commit and close. Now, one thing that's important to note is if you're doing this using a Python file, every time you run that Python file, it's going to do all the commands. When we added that column, we added that line, we are also running this again from earlier, where let's go to here, when we inserted it into, we're essentially running this again because that's still in that same Python file. So we're just going to have two identical rows. And you'll also see that the patient IDs match, which that'll be something to look at and kind of talk about and fix later. But just so that we're all on the same page, we're going to have, if you're working through the terminal, just add that another copy row. And you can look at the table using our select star from smokers. So this is somewhat similar to when we were looking at what tables exist, or what tables exist. But now we're actually looking like at the actual table's data. And so that's using the select command. Star, this just means all. So select all the data from the smokers table. And you can see here we have a nice table. And thanks to using the headers and dot mode, we were also able to get column names and a nice looking table. But now we're on the same page. We have two identical rows. Now, what about actually updating the data for this new column we added? Right now it is null. You can see that it's null right here because we added the column, but we didn't add any data there yet. What we would first think about doing is using that update command, followed by what we're going to update, which is the smokers table. Okay, what are we going to do for the smokers table? We're going to set, and then we have the column name, which was height. That was the column we just added. And we're going to set what that's going to be equal to. And finally, we're going to say where this is going to happen. And where this is going to happen is for the patient with ID 1. Now you might think, wait, we have two patients with ID 1. So what's going to happen is we're not going to have an error, but every single place where the patient ID is currently 1, it's going to also add that height. So what you're seeing there is, now we can use these filters in really cool ways. You can see here, what I'm going to do is I added a new column for what we're going to call the weight class, and the data type is going to be text. So it's the same kind of thing, add column and then weight class text. This is the data type. And then what we're doing is we're going to go, okay, we want to fill in this column as well now. Set, just like earlier, the column name, set weight class, and we're going to set it equal to healthy weight. But we're not done. Look, there's no semicolon at the end of this. We have another line, which is our kind of conditional statement, where again. Now, where are we going to do this? We're going to do this where the weight is greater than 50 and weight is less than 100. And so keep in mind, again, it's going to do this. We have two duplicate columns, so both of these are going to match. And what we're going to end up seeing is, oh, pretty cool. I mean, we were able to update two data places with one single command to filter for a weight class. And shows it for both. And Python, kind of similar stuff again. All right, this has already been a lot, and I'm already running out of breath. So I think that we should do some just super quick review. Where we just talked about, it's kind of for a filter, and we often use these where conditionals for select, update, and delete kind of statements, and it's used for queries, which we'll be discussing in some later videos. And you may have also seen ifs before. Now, this is more for preventing database errors when actually creating a database or deleting stuff. It's kind of like a safe place or kind of fallback. We also saw a pattern. Command followed by what the command's on, followed by a modifier or a clause or conditional. So this is a pattern that we're seeing. It's almost like English language. We have our verb, we have the target that the verb's acting on, and then modifiers or adverbs. And here's some other keyword reviews. And yeah, we already got to some pretty cool conceptual stuff so far in this video. So I hope you all stick around, because we're finally going to start really working with our database now that we know how it's set up and kind of the conceptuals behind it. So I hope you all stick along.